Welcome to FASTBytes, a series of quick and easy modules to understand the FHIR Standard. In Module 1, we look at the origin, evolution, and need for the FHIR Standard. FHIR stands for Fast Healthcare Interoperability Resources. Fast, because it's easier to understand, develop, and implement. The focus is mainly on implementers. FHIR has been developed by HL7 International. Conceptually, the FHIR Standard is based on its predecessors HL7 V2 and V3. However, what sets it apart is that it is specifically designed to align with the latest web technologies. The basic building block in FHIR is a resource. A FHIR resource can be an individual packet of information that includes metadata, text, or particular data elements. It can also be bundled into collections that create clinical documents, similar to the CCD8, but much more flexible. It is open source and has a strong foundation in web standards like the RESTful protocol, HTML, CSS, XML, JSON, RDF data structure formats, ATOM for results, and OAuth for authentication. Now let's go to the applications of the FHIR Standard. All the advantages of web technologies apply to FHIR as well. It can be used to develop healthcare mobile apps. These apps can be created on the smart platform using FHIR APIs. EHR vendors can choose the apps they want to plug and play from the ad marketplace, and provide these apps to patients and clinicians. Member-facing apps can use FHIR and allow users to access their clinical data directly from payer systems. A single standard means that members would not have to log into multiple portals. FHIR helps seamless data exchange between healthcare providers, payers, and other healthcare organizations. It is more efficient than typical document exchange processes, which were likely to transmit much more data than recipients would actually require. FHIR provides access to granular data in the form of resources, which makes data access focused, efficient, quick, and easy. Let's take a look at the origin and evolution of FHIR. The HL7 V2 standard was introduced in the 1980s and was a file-based exchange which used low memory and storage. It consisted of a delimited file having clinical information in a specific pattern and order. It was exhaustive, and only a trained person could interpret it. The challenge was that having information in the wrong order or format could affect the integrity of the message. It typically required a lot of customization in a site implementation. HL7 V3 was developed in the 1990s. This was an XML-based standard that focused on customization and support for web service technologies. There was more flexibility, and the data could be defined using schemas. It was easier to read and understand. However, it involved huge documents and very rigid structures. The interfaces developed had to be designed to handle large documents and were very complex. HL7 V2 and V3 were message-based exchanges. CCD8, which was introduced right after V3, focused more on patient documents at a given point in time, typically a discharge summary document. It was more human-readable and had a section to state the document information summary and purpose. It was aimed at standardizing clinical documents. SMART was built to have an open-source health platform where patients had the option to pick and choose apps that could be plugged into EHR systems to retrieve information. However, SMART lacked support from the interoperability community. FHIR came into existence in 2014, where the draft trial use was released. The trial use was implemented to get feedback. Post the trial versions, FHIR released its first normative version R4, which supports resources that are normative, in the sense that they would be backward compatible. It still has a mix of both normative and trial use resources. FHIR is seeing rapid adoption across the healthcare industry and is becoming a key component of digital innovation. The first major impact is on patient engagement. Traditionally, The healthcare industry does not provide the same quality of digital experience as seen in other industries like banking and retail. FHIR, being lighter than its predecessors like CCD8, makes it easier to provide powerful, data-driven consumer experiences in the healthcare industry. Because of its plug-and-play nature and alignment to REST protocols, FHIR makes it easy to integrate any web-based application and bridge the gap between wearable devices, home-based devices, fitness trackers, and EHRs. FHIR simplifies data sharing between complex healthcare applications and makes it easier for consumers to access their information anytime and anywhere. It can be used in mobile phone applications, cloud communications, and EHR-based data sharing. The faster access to information can make a significant impact to analytics and data science use cases in healthcare. This paves the way for advancements in areas like population health management, point-of-care decision support, and utilization management. This FASTByte is brought to you by Sidious Tech. Our Fast Plus solution is an end-to-end FHIR implementation suite that enables healthcare organizations to address a variety of needs, such as setting up FHIR servers, pre-built FHIR APIs, identity and access management, consent management, parsers, data ingestion, data repositories, API management, and bulk FHIR transactions. Fast Plus is supported by our healthcare interoperability team with more than 500 HL7 and FHIR certified professionals. To see how Fast Plus can address your FHIR needs, talk to us today.